All right, in 5.3 part 1, we are going to expand our study of right triangles into the coordinate plane. So first, we are just going to define our six trig functions in terms of a point on the terminal ray of an angle. Okay, we're still going to kind of think in terms of right triangles. Okay, so let's say that we take our angle, theta, and we put it in standard position. Okay, so here's where we're starting on the positive x-axis, and then I'm rotating that ray in the counterclockwise direction, and I'm ending up here on this ray. Now we're saying that the point xy is on that terminal ray. So there's a few things that we want to look at here. We can still think about this in terms of a right triangle, where the sides of the triangle are the x coordinate of that point, the y coordinate of that point, and then the hypotenuse of that triangle, we're going to call r. Okay? That's going to stand for a radius because we're eventually going to think about a circle here. We'll get into the unit circle in the next video. Okay, but for now, to find r, we actually want to think about using the Pythagorean theorem. Okay, so in terms of x and y, right, we could say that x squared plus y squared equals r squared. And then if I wanted to solve for r, I could just take the square root of both sides and say that r is equal to the square root of x squared plus y squared. Okay, so we're actually going to put that here. R is equal to the square root of x squared plus y squared. Okay, and again, the x and the y come from a point on the terminal ray. Okay, so we can still define all six trig functions here. Similarly to what we did before, we're just going to be using this coordinate point. So the sine of theta would be opposite over hypotenuse. That would be y over r. The cosine would be the adjacent side over the hypotenuse. That would be x over r. The tangent would be opposite over adjacent, so y over x. Now, for tangent to exist, for it to be defined, we do have to specify that the denominator, which in this case would be x, cannot be 0. Now, we didn't necessarily have to specify that up here because r will never be 0 unless the point that we're given is 0, 0, and that wouldn't even make sense for talking about an angle. Okay, so now our other three trig functions are just the reciprocals of these. So since sine is the y coordinate over r, the cosecant is r over y. And again, we would specify that the y coordinate cannot be 0 here. Secant would be r over x. We would specify x cannot equal 0. And then cotangent would be x over y. And we would specify that y cannot equal 0. Okay, now the new part that we're really going to take a look at is that point can be anywhere in the coordinate plane. Okay, so here we were able to easily see these in terms of a right triangle. But now what if I've got an angle that's greater than 90 degrees? What if that point is over here in the second quadrant? It would be the exact same process. Okay, if my point is over here, these six ratios will still be the sine, cosine, tangent, cosecant, secant, and cotangent of this larger angle. Now, we'll look at an example of this here in a minute, but we can actually just draw a right triangle. Okay? We don't have to memorize these six relationships. We can just draw a right triangle here and say, well, this angle would have the same trig values as this angle. All right, so if we say that this would be my y coordinate, or yeah, this is my y, this is my x, we could just look at this right triangle here. Now, to do that, we would always want to draw aside from the point to the x-axis. And again, we'll look at an example of that here in just a second. Okay, but so that's the new idea. We're going to find trig values of any angle, right? Could be greater than 90 degrees. So we're expanding just from right triangles. All right. So in our first example, okay, let's say that theta is an angle whose terminal side contains the point -2, 5. Find the exact values of all 6 trig functions. So based on what we just talked about, we could do this without even drawing a picture. But I think it's usually best to draw a picture. Okay, so the point -2, 5 would be like right here. So if we connect that to the origin, what we're saying is this is the angle here that I want to find the trig values of. This is my theta. But what we can think about is drawing a right triangle here and saying, well, that this side length would be the x coordinate, that would be -2. This side length would be 5. And then the hypotenuse, well, we need to calculate that. Okay, we're calling that r, right? So we'll say r equals the square root of x squared, which would be -2 squared, plus 5 squared. Okay, and again, we're just using the Pythagorean theorem to find that value. So that would be 4 plus 25, so we'll get the square root of 29. Now, if we could break this radical down, we would want to do that at this point, but the square root of 29 does not reduce, so we just have the square root of 29 here. So to list out my trig functions, the sine of theta, okay, again, we can either just think about memorizing this, right? We could say it's just the y coordinate over r, which would be 5 over the square root of 29. Or we could look at our triangle and say, well, the opposite over the hypotenuse would be 5 over the square root of 29. Now we do need to rationalize since we have a square root in the denominator. So multiply top and bottom by the square root of 29, and we'll get 5 times the square root of 29 over 29. Then same for cosine. So here we will have -2 over the square root of 29. So we are starting to get into where these values could be negative, right? So that's something that we need to keep track of, and that's a big reason why drawing a picture for a lot of these is helpful. Again, we need to rationalize. So we'll get -2 square root of 29 over 29. Then tangent would be opposite over adjacent, or again, just y over x. So 5 over -2, or we can just write that as -5 over 2. Then our other 3 are just reciprocals. So cosecant is the reciprocal of sine. That would be the square root of 29 over 5. Secant is the reciprocal of cosine. So that'll be negative square root of 29 over 2. And finally, cotangent will be the reciprocal of tangent, so -2 over 5. Okay, so you could, memorize these relationships, or we can just draw a picture and still use right triangles. Okay. Next, we want to talk about the signs of the trig functions. Okay, so again, we've essentially just looked at where everything is positive so far. Right? So what we're saying now is our angle is not quadrantal, which remember that means the terminal side is on one of the axes. So we're saying that's not the case. The terminal side is in one of the quadrants. Then we can automatically know the signs of our trig functions. Okay, we just mentioned, okay, up here that the sine is going to deal with the y coordinate and the cosine is going to deal with the x coordinate. So if we think about that, the y coordinate is positive in the first and the second quadrant. What that means is that sine will be positive in the first and the second quadrant. Sine would then be negative in the third and fourth quadrant. Then if we think about cosine in terms of x, well, that means that cosine would be positive in the first and the fourth quadrant, and cosine would be negative in the second and the third quadrant. Okay? So if sine is just in terms of y, then cosine is in terms of x. Okay? Now, r is always positive because r is a distance, so that's not going to affect anything. Okay? So again, if x is positive, then cosine is positive. If x is negative, cosine is negative. If y is positive, sine is positive. And if y is negative, sine is negative. Okay? So the other of the big three trig functions, then tangent. Tangent deals with both x and y. Tangent is tangent is y over x. So if both the y and the x coordinate have the same sign, right? If they're both positive or both negative, then tangent will be positive. Okay, so tangent is positive in the first quadrant, and tangent is positive in the third quadrant. Okay, tangent would then be negative in the second and the fourth quadrants because one of those two functions is negative. Okay? If we've got a positive divided by a negative or a negative divided by a positive, our final result will be negative. Okay? There is an old way to remember which of the big three are positive where. Okay? All of them are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third. And only cosine is positive in the fourth. Okay, so the way to remember that is all students take calculus. Okay, all students take calculus. Tells you which of the big three trig functions are positive as we go around our quadrants. All of them, just sine, just tangent, just cosine. But again, I would prefer to think about that in terms of just, if the x is positive, cosine is positive, and if the y is positive, sine is positive, right? Now, for the other three, cosecant, secant, and tangent, since those are just the reciprocals, that doesn't change sign, right? So if sine is positive, cosecant is positive, right? Cosecant and sine will always have the same sign. Tangent and cotangent will always have the same sign. Cosine and secant will always have the same sign. Okay? So let's take a look at a few examples here. If we know that tangent is negative, right? If it's less than 0, that means it's negative, and cosine is positive, where does our angle lie? In what quadrant? Okay, well, if tangent is negative, that automatically tells me we're in either quadrant 2 or 4. Right? Tangent's negative in quadrants 2 and 4, and cosine is positive. So cosine is the x value, right? So that means that we would have to be on this side of the y-axis, right? We're either in 1 or 4. So if we're either in 2 or 4 and 1 or 4, we would have to be in quadrant 4, right? Tangent is negative and cosine is positive in quadrant 4. In our second example, sine is negative and cosine is negative. Okay, so sine being negative, that means the y value is negative, and cosine being negative means the x value is negative. That means we would have to be in quadrant 3. Now, one way to remember which between cosine and sine, which one goes with x and which one goes with y, you go to Canton South, right? CS. Cosine deals with the x value, sine deals with the y value, okay? CS, Canton South, all right? So let's look at an example here where we're given one of the trig values and then told one is positive or negative, okay? And we have to figure out the rest of the trig function. So this combines both of those last two ideas. We would definitely want to start with a picture here. All right, well, first we need to figure out what quadrant we're in and then finish our picture. So tangent is 3 over 2. That means tangent is positive. So I've got a positive tangent value and a negative cosine value. So if tangent is positive, I'm either in quadrant 1 or 3. And then cosine is negative. Cosine is the x, so that means I'm on this side over here. The x value is negative. That means I would have to be down here. So my angle is going to be down here. I can draw my terminal side of my ray down here. Now, to finish our right triangle, remember we said you would always connect the point to the x-axis. That'll get my right triangle. And then tangent is y over x, right? So that tells me that the y value, the x value, are 3 and 2. Now, since we're in quadrant 3, we know that both of those are negative. Okay, that's important here. We know that both of those are negative. X value is negative and the y value is negative. So now I need to find this value, the third side of my right triangle, which we called r. Right? So r is going to be the square root of -2 squared plus -3 squared. So that'll be 4 plus 9 is 13. So this side is the square root of 13. Okay? And from that then, we can list our 6 trig values. So sine, and again, we're just looking at this angle here in our triangle. Okay? So I can draw in theta here. It would always be the angle that is where the vertex is the origin, okay, when we're drawing a picture like this. So sine is going to be opposite over hypotenuse, -3 over the square root of 13. We would need to rationalize, so times square root of 13 over square root of 13. We'll end up with -3 radical 13 over 13. Then cosine of theta would be adjacent over hypotenuse, so -2 over the square root of 13. Again, need to rationalize, so we'll get -2 square root of 13 over 13. And finally, tangent, we know already, is opposite over adjacent, so -3 over -2 would just end up being +3 over 2. And then the other 3 are the reciprocals. So here we'll have -square root of 13 over 3. Here we will have -2, -square root of 13 over 2. And the cotangent will be 2 over 3. I forgot theta. There we go. All right. The last idea then is reference angles. Okay, we're just going to touch on these here. We'll use these more later on to solve problems. Okay, we're just going to introduce them now. Okay, so a reference angle is just the angle that is created closest to the x-axis, essentially. Okay, so if our angle is in quadrant 1, theta will just be equal to the reference angle. And the notation here, okay, if we put a little tick mark, right, or a prime, we're saying that's the measure of the reference angle. If we're in quadrant 2, right, if this is my whole theta, then the reference angle is just the angle that makes with the x-axis over here. To find that, we would just take 180 minus our original angle. That'll get me the reference angle. Okay, if we're in quadrant 3, right, going all the way down here, I would take my original angle and subtract 180 to get what's left over here. And then if we're in quadrant 4, I would take 360 minus my original angle. Okay, so Essentially, what we're doing, right, if we kind of think back to this example, we actually used a reference angle here when we drew this right triangle. Our angle, our original angle, which is actually this whole thing here, okay, we used the reference angle, just the angle that is created with the x-axis. So, to find the actual measures of those reference angles, we have to figure out what quadrant we're in. Okay, so here, in our first example, 250, well, that's going to be in the third quadrant. Okay, we kind of want to start to just be able to recognize that this is 90, this is 180, this is 270, and then all the way back around would be 360. So 250 is in between 180 and 270. I know it's in quadrant 3. So to find the reference angle, all I need to do is take my original angle, which is 250, minus 180, and that would give me the reference angle is 70 degrees. Okay, so if I had a 250-degree angle here, the leftover piece from the x-axis to that terminal side would just be 70 degrees. Now, this next example is in terms of radians. Okay, now you have an option of converting this to degrees and thinking about it that way, but we would want to give our final answer in radians, right? If we're given something in degrees, our final answer should be in degrees. If we're given something in radians, our final answer should be in radians. So we also need to start thinking about the radian measures around here. So this, an angle of 90 degrees would be pi over 2. An angle of 180 would be pi. An angle of 270 would be 3 pi over 2, and then an angle of 360 would be 2 pi. So 3 pi over 5 is actually in between pi over 2 and pi. That means we would be in the second quadrant. So to get our reference angle, we would take 180 minus theta, or in this case, since we're talking about radians, 180 is pi. So my reference angle in terms of radians is going to be pi minus 3 pi over 5. This we can convert to just 5 pi over 5, right, to get common denominators. So 5 pi over 5 minus 3 pi over 5 would be 2 pi over 5. So that reference angle in radians would be 2 pi over 5. Our last example here, we are given an angle of 5.75. Okay, now this is kind of strange because there's no pi, right, and there's no degree symbol, right? If there's no degree symbol, it's given in radians. So this is 5.75 radians. Well, we know that there are 2 pi radians all the way around. 2 pi, we said, is about equal to 6.28. So this angle is actually going to be in quadrant 4, right? It's almost all the way around. So if we're in quadrant 4, to find the reference angle, we want to take 360, or if we're talking about radians, 360 is 2 pi. So 2 pi minus 5.75. So that we would actually use our calculator for. Okay, so 2 pi, again, is about 6.28, but we can just plug that into the calculator here. So 2 pi minus 5.75 gets me, and since our original number was rounded to 2 decimal places, let's go to 2 decimal places, so 0.53. So again, that's in terms of radians, 0.53 radians, okay? Now, if we would prefer degrees, we can definitely convert this to degrees, okay, and do our calculations in degrees, but since our original problem was given us in radians, we would then want to convert back to radians. Okay, we could do the same thing here. We could convert this to degrees and do our calculations in degrees, but our final answer should be 2 pi over 5. Okay, so again, we're not going to use these a ton right now, okay, but just to introduce what a reference angle is, we will use these more in the near future. All right, so that is it for this lesson. The final question is going to pop up asking you what questions you have.